The Gadgets 21 video came about from questioning as to whether this 5-volt reference box, which is based on a switching regulator, whether that switching could introduce some noise into our waveform. And I thought, what better way to answer that question than to go ahead and build a linear regulator based 5-volt reference box, Gadgets number 21, and then have two waveforms taken by each side by side and see if there was really a difference between the two. And the conclusion of the video is that there was no discernible difference and that either one of these reference boxes would be adequate for the type of automotive work that we do. The fact remains that there is a switching regulator in this and that it must be producing a certain degree of noise. So I thought we would revisit number 21 and take a closer look at the output of this reference box and compare it to the output of this one. It'll give us a good excuse to use the LOTO OSC2002 that I've already featured on the channel, and we're going to use it with its native Windows software. We'll start out with the linear 5-volt reference box, connected directly BNC to BNC on channel 1 of the OSC2002. By now you guys are familiar with my use of 3-wire RCA cables for this type of work. I've taken the one that I've made with alligator clips. We've got 5 volt and ground going across a 1 kilo ohm resistor. This yellow one is the return, the signal, going through the center pin here to the center pin of the BNC through to our oscilloscope. If there was any activity, any switching, anything going on across that resistor, we will see it through here. Let's start the oscilloscope. Let's power on the 5-volt reference box and let's zoom into it. So we're looking at what? 4 millivolts peak to peak. This is very, very quiet. Now we have the switching 5-volt reference box. Same setup, using the same 1 kilo ohm resistor. But look at that. 50 millivolts peak to peak. The frequency is at 40 kilohertz. Here's something else that's kind of interesting. We're going to switch a resistor here. And instead of 1 kilo ohm, we're going to put 1 mega ohm. You'll notice that not only did the amplitude change, but so did the frequency. We're now at 22 millivolts peak to peak, and the frequency is now at about 2.5 kilohertz. There is switching noise, of course, and the greater the load, the higher the peak to peak values and the higher the frequency, because there's more switching going on. So why wasn't it prominent in the waveform comparisons in Gadgets number 21? That's because those sensors, that pressure transducer in particular, places a very, very light load. It's about 3 milliamps. So it's more along the lines of what we saw when we were testing this out with a 1 mega ohm resistor, where we're getting now maybe 20 millivolts peak to peak at a 2.5 kilohertz frequency. And over a 3 or 4 volt range, it's kind of embedded in there and you don't really spot it. In a sense, the conclusion at the end of Gadgets 21 is still accurate. You can use either one of these 5-volt reference boxes for the type of work that we do. The original reason I was staying away from a linear regulator based 5-volt reference box was because of its inefficiencies, but that turns out to be mute. The draw on these sensors is so small that this thing can go on and on with these 9-volt batteries, and it's not an issue. If you're into automotive work and you build but one of my gadgets, it should be a 5-volt reference box. They're extremely handy. And if you're going to build a 5-volt reference box, it should be this one, the one that was featured in gadgets number 21. Hit the like button, subscribe, support the channel. Catch you guys later.